Hello guys, today we're talking about 4 and AMC10A problems 6 through 10. So what is the minimum number of successive swaps of adjacent letters in the string A, B, C, D, E, F that are needed to change the string to F, E, D, C, B, A? So we can start by writing A, B, C, D, F. Swapping it with E, we get F, E. Swapping with D, we get F, D. Swapping with C, we get F, C. Swapping with B, we get F, B. And then swapping with A, we get F, A. This is 5 moves. So I'm just going to undo this real quick, and I'm going to just write it on the side. So after that, we get F, A, B, C, D, E. Doing the same, we swap E with D, we get E, D. Swap E with C, we get E, C. Swap E with B, we get E, B. Swap E with A, we get E, A. This is 4 steps, and this results in us getting F, E, A, B, C, D. And we start to see a pattern, but let's just continue. We switch, switch. We get F, E, D, A, B, C. And obviously for ABC to CBA, there's 3 swaps, so we add 2 plus 1. This is just 5 times 6 over 2, which is just 15. Next question, problem 7. The product of 3 integers is 60. What is the least possible positive sum of the 3 integers? So basically, we could write out the multiples 60, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 10 times 6, ... So obviously, these are way too small to be able to be a positive integer. 10 times 6. So if we add just 10 plus 6, 16 is not an option. So we have to think creatively. We have to make 6 a multiple of 2 negative integers. So 10 times negative 2 times negative 3, or 10 times negative 1 times negative 6. And we have to add up the 3 integers. This gives us 5, this gives us 3. So 3 is our most smallest integer. Number 8. Amy, Bomani, Charlie, and Dario work in a chocolate factory. On Monday, Amy, Bomani, and Charlie start working at 1 p.m. and were able to pack 4, 3, and 3 packages respectively every 3 minutes. At some later time, Dario joined the group, and Dario was able to pack 5 packages every 4 minutes. Together, they finished packing 450 packages at 2:45. So we can separate this. So let's say this is 1 p.m. and let's say this is 2:45. In the middle, there are 105 minutes. Let's say this is the part where Daria joins the crew. So that means that X, and this is 105 at 5X. So for the first X minutes, every 3 minutes, they pack 4 plus 3 presents. Or is it not presents? Packages. Like above. Just 10X over 3. And for the rest of the time, every 12 minutes, Amy packs 16 packages because there's 4 3-minute intervals in 12 minutes. Times plus 12 plus 12. And since Daria packs 5 packages every 4 minutes, then she packs 15 packages in 12 minutes. So this ends up to be 105 minus X times 55 over 12. Obviously this plus 10X over 3, bring it down. This is equal to 450. Now we multiply 12 over. We get 105 times 55 minus 55X plus 40X is equal to 450 times 12. But 450 times 12 is in quick math. 95, 4, 5/400. So bringing it down here, we get negative 15x. 55 times 105 minus 15x is equal to 5/400. And well, the good thing about this is that we can divide by 15 on both sides. 105 is 15 times 7, and 15/400 is 15, so this is 3, so 5/400, let's just do the division. 15, 3, 45, 90, 60. So dividing by 15 on both sides, we get 55 times 7 minus x is equal to 360. Adding x on both sides and subtracting it, 55 times 7 is 35. 35 times 360 is 25. So x is 25. So after 25 minutes pass, Daria joins the group. Problem 8 from 9. In how many ways can 6 juniors and 6 seniors form 3 disjoint teams of 4 people so that each team has 2 juniors and 2 seniors? Let's say this is group 1. This is group 2. This is group 3. Group 1, out of the 6 juniors, we need 2 juniors to join the team. So 6 choose 2 ways. And we need 2 seniors to join the team. 6 choose 2 ways. Out of the 6 seniors, 2 seniors need to join. And for group 2, junior, junior, senior, senior, there's 4 juniors left to choose from. And we need to choose 2 to join the committee. And like here, 2 choose 2, 2 choose 2. So 6 choose 2. So 6 choose 2 is 6 times 5 over 2, which is just 13. Sorry, not 13, 15. And 4 choose 2 is 6. So we get 15 squared times 6 squared. 2 choose 2 is 1, so we don't consider that. This is 8100. Keep in mind, order doesn't matter. We don't have to choose group 1 first. We can choose group 2 first or group 3 first. So we divide by 3. So let's say we just choose group 1 first. Then we could choose group 3 and 2 instead of 2 and 3. So we have to divide by 2 again. Or we could just do it in one step and divide by 3 factorial. So this is just 1/350. And yep, that's our answer for the question. Lastly, problem 10. Consider the following operation, giving a positive integer n. If n is a multiple of 3, then you replace n with n over 3. If n is not a multiple of 3, then you replace n with n plus 10. So if we start with n equals 100, what's our value that we get after performing it exactly 100 times? So 100. Not a multiple of 3, so we add 10. Not a multiple of 3, so we add 10. Aha, this is a multiple of 3. Let's divide it by 3. 40, not a multiple of 3. 50, not a multiple of 3. So now we continue this down. We continue this down. I don't know what's wrong with this. So we notice that there's 1, 2, 3, 4, 5, 6, 7. So there's 7 operations until this loop, because our loop is just 10, 20, 30. 10, 20, 30. So 100 minus 7 is 93. And so since this is a loop, we know that every multiple of 3 lands on 30. And 93 is conveniently a multiple of 3, so our answer is 30. Thank you for watching.